Hello, and welcome to this wonderful evening talk. Actually, evening talk in my case. And Josh Long, it's like daylight, so it means morning there in San Francisco, yes?
Yeah, morning, which is nice.
Oh, yes.
Cup of coffee and a conference talk, first thing in the morning.
Absolutely great. So once again, it's very nice to see you. By the way, last time I saw you, it was night there. I mean, it was midnight when you were doing the talk, and now it's daylight, and it's beautiful view from like from this window in San Francisco, all the way down from California. It's so great to be here with you again. So my great buddy,
Likewise,
Josh, and well, just how are you? Is it actually cold, or how's November there?
Well, it's kind of cold. We just had a crazy storm. What?
As I said, still October. I had a feeling it's November because it's cold here, and that's why.
Oh yeah. It feels like November. We just had a crazy storm, a very historic storm, just a few days ago. The fourth wettest day in San Francisco history. Like, it's crazy cold. There was wind that passed through all the buildings, and so you could hear all the buildings howling. You could hear the whistling, the sound of the air rushing by all the buildings. It was really loud. You would sit in the living room and it was like, crazy. We don't get that weather ever.
You're pretty high, so you're still like, was it shaking?
It's worse up here because we're up. There's more building.
I see. Okay, but everybody knows like San Francisco is the city of like permanent spring, like for us, for example. And you are wearing this wonderful T-shirt, so it's very nice to still get some spring in this autumn. And yes, lovely to let some spring in this autumn talk. So wonderful topic. So first of all, Bootiful, because it's boot, then Spring,
right,
and then GraphQL. So for many of us, it's a pain point, but I think that you are like going to tell us that GraphQL is not such a pain if you're using Spring, and it's beautiful.
Yeah.
So I really impatient to see this video. I think that all the public is impatient to see this talk. Just from my side, I would say I will monitor for questions, and just don't hesitate. You can ask your questions in any language. I will do my best to translate it, and ask them to ask Josh about them. So Josh, thank you so much. We're impatient to see your talk, and just go ahead.
All right. Thank you, Dimitri. My friend, I've missed you. I wish we could be in person, of course. Obviously, it's been so long since we've been in the same room together, but it's good to see you as well. I'm feeling a little slow today. I'm not feeling so great. I got my booster vaccine on Sunday, and I just feel, today. But I really seeing you made me feel better. I feel happier and more optimistic about the future again. So good to see you, my friend. Okay, everybody, my name is Josh Long. I'm so glad to be before you, even if for the moment it's just online. I wish that we could be together in person, obviously, but that day will again come. I expect that we'll have that opportunity sooner rather than later. Fingers crossed. We're going to talk about GraphQL and Spring today. But before we do, let's get some housekeeping out of the way. First, if you want to follow along at home, and since you're all home, that might actually be easier. Here's the code. If you have questions, comments, feedback, whatever, want to engage with my brand, you can find me on the internet. Right there I am on Twitter, LinkedIn, email, podcast, YouTube, Twitch, stream, and a blog, right? And lots of stuff there. So just take a screenshot of that one slide. That's my slide. I've just given up on the pretense of slides at this point. I think I've declared slide bankruptcy because I don't use slides. And when I do, they're just more trouble than they're worth. Because what if your program wants to update itself or whatever? It's like, what doesn't fail me? It's rock solid and dependable. Text, Sublime. It never fails on me. So I'm happy to have this. So find me there. And let's get going. Okay. So we're going to talk about GraphQL. Now, GraphQL is a solution to a problem that I expect more and more people are having these days. We see all over the place. We see people. Sorry, there's road noise downstairs. We see people building microservices, right? This is a natural consequence of the need to go faster. People are moving to microservices because it allows them to build better services more quickly. It allows them to take large code bases and break them into smaller, self-contained, independently deployable chunks. And this is very valuable because it allows people to, as a small team, move work into production. I love production, right? And so I'm really a big fan of this. This is called continuous delivery. And continuous delivery, in order to make it work, you need to embrace lots of different technology decisions that optimize for speed. That is to say, they allow you as an organization to iterate, to go more quickly from concept to customer, to have an idea, to deliver it into production, to validate that it works, and then try again, right? The loop that you have to go through is very, very important. And so microservices, along with continuous delivery and continuous integration and test-driven development and all these other things, cloud computing, all of them are about optimizing for speed. And when you move to microservices, obviously, technologies like Spring Boot make it very easy to build small services that have security, that have observability, that are deployable inside of a container, that can be turned into native images using Spring Native and GraalVM. There's a lot of opportunities here when you use Spring and Spring Boot. But the question that people often ask then is, okay, well, I've got all these different microservices, and there's some things that are being handled in a redundant fashion at each microservice, right? So I have Spring Security in each different microservice that takes in the current request and extracts out the token and turns that into a Java security principle. Okay, that's pretty redundant, but that's okay, because again, the big picture is that we get more throughput by having redundant features across all of our deployed instances. So you move to microservices and you get higher throughput, even though it feels like sometimes it's a little bit slower because you have these redundant concerns. But there's still a wish, there's still a hope that we can, wherever possible, not be wasteful. We don't want to waste resources. We just want to, where appropriate, use resources in a way that allows us to serve each microservice without being wasteful. And so one place where this comes into play is at the edge. The edge service is a service that lives at the logical edge of your architecture. It is a thing that accepts incoming requests and adapts them or translates them to the downstream microservices. So you might have HTTP services or RSocket services or gRPC services or whatever, and all these different services do different things, but you want to provide a single view for the users at the edge. And in previous, if you've seen me talk before, you know that I love reactive programming because that makes service orchestration and composition very easy. It's very, very powerful. It's very clear and clean how to do reactive service orchestration, scatter, gather, service orchestration, and composition. I also love Spring Cloud Gateway because Spring Cloud Gateway makes it easy for me to proxy downstream services and make them accessible to the downstream clients, right? So again, I'm sending requests from the clients, from the iPhones, the Androids, the PlayStations, the Xboxes, the Rokus, the iPads, whatever, all these different things. I'm sending the requests from those things through the edge service, and then I'm routing them to my downstream services. And the reason I have this edge service is because my clients have different use cases, right? They have different demands. They have different scenarios that they need to care for. And also it's simpler because even though each microservice has security, it doesn't help if every single client has to connect to 10 different microservices, right? That's a lot of work, especially if you're on an Android device or an iPhone or whatever, and you're going through a tunnel or you're far away and you've only got 3G. The last thing that you should do, the worst thing you can do, is to make every client connect to all your different microservices. Instead, it's better to give the client a particular view of the data. That's the edge service. That way, they can authenticate only one time, and that way, they only need to speak one protocol. So your different microservices might speak different protocols like gRPC and HTTP and RSocket, but your client doesn't need to know about all that. They can just speak the one protocol that they've agreed on. Also, things like routing and compression and all that, you can handle that at the edge. That way, if a client needs a particular view of the data, again, that's all handled at the edge. So this seems like a winning strategy, and it is, of course, a usable, workable strategy. It's worked for a lot of organizations for many years. But at some point, you get enough clients, then this starts to not work as well as it could. And this is exactly what happened with Facebook back in 2012. They had a bit of a tension. They had a bit of a conflict. They wanted to build lots of small, independent, reusable, bounded context services, right? Lots of small, independent services. But their clients wanted all the data in one place. They don't want to go to 10 different services. They don't want to do network calls for 10 different things on the client, right? That burns a lot of battery. It's very inefficient. And some clients, like your HTML browser, won't even let you do 10 different requests at the same time, right? You have a pool basically in the browser. Most JavaScript applications can only make a limited number of requests at the same time. So then the browser starts serializing the work. So this is not practical. It's much better to give the client a view of the data where they can make one request and all the multiplexed responses are put in the same stream somehow. And so, we talked about some strategies. We talked about reactive programming and Spring Cloud Gateway for micro proxies. But again, if you have enough clients, this means you're constantly building edge services. And one thing that you can do, like what Netflix did, Netflix built Zool. Zool is a proxy that they built to make it easy or cheap or declarative to make requests to the downstream services, to proxy the downstream services. Zool supports reloadable configuration. That is to say, you can deploy the rules for your Zool proxy, and it gets reloaded automatically. This is great if what you're trying to do is very minimal. It's just very low touch, not very business logic intensive. But as soon as you start trying to involve business logic, well, then it makes more sense to build a proper service. This is why I like Spring Cloud Gateway these days, right? Because it supports reloadability, but it's also a proper API. Well, anyway, Facebook, they were having this problem. They were having lots of different clients, and they had lots of different services. And the clients, as they added new clients, they kept on having to add new edge services. And this became a problem. This is back in 2012, so almost a decade ago, right? And so they decided they're going to build something to make it easier to integrate this big graph of services into one view, and that's GraphQL. They open sourced GraphQL in 2015. Now, in 2012, the first Avengers movie came out. In 2015, the second Avengers movie came out. So they created it in 2012, and then they open sourced it in 2015. I just think that's very interesting that they released GraphQL at the same time as they had a movie about a super robot that wants to take control of all the world's data. I don't know if there's any relationship there. It just seems very funny. Anyway, so GraphQL is very powerful. It gives you a way to think about integration. Now, you don't have to use it for integration. It doesn't have to live at the edge. I just think it has a particularly interesting role to play there. So my friends, with that understood, let's go ahead and build our first GraphQL application. We're going to do so, of course, by going to my second favorite place on the internet. Obviously, my first favorite place on the internet is production. I love production. You should love production. You should go as early and often as possible. Bring the kids, bring the family. The weather is amazing. It's the happiest place on earth. It's better than Disneyland. But if you have not been to production, again, you can begin your journey here at start.spring.io. And what I'm going to do is I'm just going to call this whatever, Edge, okay? And we're going to use the latest and greatest version of Java and the latest and greatest version of Maven and Spring Boot and all that stuff. Now, I see before me 3 different choices for the version of Java. Java 17, 11, and 8. Java 17 is the current long-term supported version of Java. Java 11 is an old, previous long-term supported version of Java. And Java 8 is a terrible version of Java that you should not be using under any circumstances. It is technically inferior in every way to Java 17. It's slower, less performant, less robust, less syntax rich, less secure. It's also morally inferior to Java 17. You will not like the look of sadness and disgust and despair in your children's eyes when they see that you're using Java 8 in production. Don't do it. Be the change you want to see in the world. Do the right thing. Use Java 17. So we're going to go ahead and add that. And now I'm going to add just the reactive web support. I'm going to add the Spring security support. And I think that's it, actually. I think that's enough for now. I want to add GraphQL. I really wish I could add GraphQL here. But you see, this project is not yet GA. We built this project by building on top of the GraphQL Java, the official GraphQL Java Spring integration. We are developing the Spring GraphQL project with that team. So the official team working on this GraphQL Java, the most popular, most widely deployed version of the GraphQL API for Java, that's what we're building on. So even though it's a brand new project for us, it's not a brand new project for the world, right? For the ecosystem. You're not building on something that has not been tested. In fact, quite the opposite. Just the other day, the GraphQL Java project announced that, Twitter announced that they were using the GraphQL Java project in production at scale, and that it was a lot faster than the old Scala-based GraphQL project that they were using before, right? So they had a implementation that they were using internally, and they switched to the GraphQL Java project, and it was allowing them to handle Twitter scale demand at much better performance. That's the version of GraphQL that we're going to build on when we use Spring GraphQL. And remember, it's the Spring GraphQL integration that's being developed by the Spring team, by the people that have built the web support in Spring, the RSocket support, all this stuff that you know and have used before in Spring Framework. That same group of people are the ones that are working on the GraphQL Spring integration, okay, along with the GraphQL Java team. So even though I want to add it, it's not yet here because it's experimental, but it's not that experimental. Like I say, it's a layer on top of something that has already been around and is in use at scale in production in many different organizations. So we'll go ahead and hit generate, and I'm going to open this up in my IDE, okay? So Edge, would I like to? Yes, please, go for it, IntelliJ. Oh, I had so many issues with IntelliJ yesterday. It was being very bad, very naughty. Let's see, trust prod, yes, okay, trust. I ended up downloading the EAP, the early access, which normally IntelliJ is like perfect, right? I don't know what was going on, but it seems okay now. Hopefully everything will be all right. You don't know. We don't know. It's not possible. Okay. So good. So here we go. So we have to add this to our build ourselves manually. And because it's a milestone, I'm going to cheat a little bit. I'm going to go back here. I'm going to hit explore, and I need to get the Maven repositories and the plugin repositories for milestones. Okay. So I'm adding that in manually. See, Spring milestones, etc. And now I can go up here and I can add the experimental, not yet GA dependency, right? So dependency, GraphQL Spring Boot Starter or Spring Framework Experimental, and there we are. Okay, so there's my Spring Boot Starter. All right, good. So now let's go back to our Edge service, and what we're going to do is we're going to build a simple example using the low-level GraphQL Java API, so that you understand how it works, okay? Okay, so we're gonna create a configuration class, and we're gonna say, greetings, runtime wiring configurer implements runtime wiring. Oh, I have to add this build, don't I? Reload. Come on. Runtime wiring. Is it extends runtime wiring? Let's see. GraphQL, yeah, it's there. So runtime wiring configurer. Well, that's all. We've already gotten ourselves into trouble. Oh, is that it? Does that work? I extends. And voila, there we go. So this is an interface, so I'll implement it, right? Implement, and this is a configuration class, or it could just be any bean, really, I guess. So it's the job of this component, actually. Component makes more sense. The job of this interface is to describe how we create endpoints, right? And so in GraphQL, in Spring GraphQL, this is schema centric. So you start with a schema. So you create a directory over here called GraphQL, in which you put a file called schema schema.graphqls. Okay, and here I'm going to create a query. Now, in GraphQL, you have a few root types, and these root types are well known, but they're the same as all other types, but it's just expected that you're going to have a type called query in all of GraphQL programs. So let's create an endpoint that does hello world, okay? So we're going to have a field, this is called a field, of type string in the type query. So we need to implement that here. We need to provide the implementation for that here. And so what we will do is we use the builder. We'll say builder.type query. And we will say that we're going to create a new unary operator, which gives us another builder, right? And we will say b.data fetcher. And the thing that we expect on the left is the name of the field, so hello, and then a new data fetcher. Okay, now data fetcher is very important. Think of data fetcher as kind of like HTTP servlet, right? It's the very low level API that you use to teach GraphQL how to resolve data that they're asking for. So somebody will ask for this field called hello. We want to give them that field, okay? So we will say, okay, great, hello, env. We're going to say env dot, well, we can just say hello world, actually. Let's just do that for now, okay? Hello world, good. So there's our very simple API. It's actually very convenient. It's not so bad if you use lambdas, right? Replace with lambda. There. So there's my entire GraphQL implementation, my entire service. I have a type called query and a field called hello that when somebody asks for it, I return hello world, okay? Let's try this now. Okay, it's up and running, but the problem is, of course, I have Spring security still, so I need to disable this for the moment. Just for the moment, of course. I love Spring security. There are only a few things worse than not having security. One of them is PHP, and the other one is people that try to explain cryptocurrency to me. I don't know why people bother. But besides that, yeah, you should definitely have security. Don't get rid of it. It's very important. But I will get rid of it just for now for this little demo. Let's go ahead and reload. Okay, so now localhost 8080, and there's a little console. There's a little GraphQL console that you can use, right? So you go here, hit refresh, and there's this console. This is the same console that you get if you go to the SpaceX API, right? SpaceX is a company that was created by Elon Musk, and it was designed to support, to help people get to space or something like that. I don't know, whatever. But the point is, they have an API. So if you want to ask questions, they have this API that gives you an enumeration of all the data related to their launches and their CEO and all that kind of stuff, right? Okay, so we have the same thing. It's exactly the same thing. So I'm going to send a query, right? Query, and the query is going to be for hello. Okay, so I ask for that, I get the response back. Pretty trivial, but it works. Now, remember I said that there's a well-known type called query. All GraphQL projects have query, right? This is a well-known thing. Sending queries is so common that actually you can just do this as well. It's the same exact result, right? But you can, that's a shortcut. You can drop the word query for that one. Okay, so we have a field. What if we wanted our field to have a name, okay? Let's make this, let's give this a name. So we'll say name is equal to string, and then the return value is of type string. So now we will say, hello, env.getArgument, right? Name, all right, good. Okay, goody. So there's my new code. Let's restart this. Okay, and now this will no longer work. So I'll take, refresh, paste, and you can see if I do hello, it's saying you have to have a name. Notice that it supports auto completion, right? So now I can say hello, Dimitri, right? I get a response back based on the parameter that I'm sending in. So yes, it's a request, but I have parameters and I can ask questions with those parameters in mind. You know, I want this kind of thing with this customer ID, with this name, with this whatever. All right, so we understand how to do it using the low-level runtime wiring configurer. This is more or less what the API for GraphQL Java looks like. You end up dealing with this concept called data fetchers. Now, this is not very typical for a Spring application, but I wanted you to see that that is there. And if you want to do something very low level, That's how you would do it. More typically, though, we expect you're probably going to just use the controller abstraction, right? So we're going to call this Edge GraphQL, no, GraphQL controller. And the controller type here is an annotation that you've probably seen in Spring. You see this annotation when you use RSocket or WebSocket support or REST APIs or HTTP MVC APIs or all sorts of things. And you can use it for GraphQL as well. Remember, this annotation is not HTTP only, right? It doesn't have anything to do with HTTP. It's a generic annotation for controlling things, right? So it's a GraphQL controller as well. And yes, we are using HTTP for GraphQL for the moment, but there's no reason that you need to. This is one of the things I love about GraphQL. It's very pragmatic. It doesn't care what protocol you use to talk to it. Okay, so now let's create a new handler here called Schema Mapping. The type will be equal to query, and the field is equal to hello, okay? And I will say hello, and the argument is the name that we saw earlier. I'm going to say return hello, right? Just like before, very simple. Now, I'm using the reactive web support here in my GraphQL application. The nice thing about Spring GraphQL is that it does not care what runtime you're using. You can use reactive, asynchronous, non-blocking, highly scalable I/O, or you can use imperative, traditional I/O. It's okay. It's the same GraphQL project. We support both runtimes. Okay, so now we go here, and there we go. Hello, Dimitri. Maybe I should have added, this so we can see two extra exclamation marks so we know what's going on, because otherwise, whoops. Oh, there you go. So 2 exclamation marks, right? Okay, good. So now we have re-implemented the same thing using schema mapping. Schema mapping is we're mapping this controller handler method to this schema called hello in the type called query. Schema is very much an important part, but we are doing something very common. We are creating a schema. We are creating a schema mapping for a query. Well, this is very important. Everything will live in query, right? You start your design in the query type. So Spring GraphQL has another annotation called query mapping, and query mapping is actually just schema mapping for type query, and the name of the field is taken from the method name. So this is the same. It's exactly the same, right? So we can restart. Okay, and query mapping is you can override things. This is kind of like the relationship between request mapping and get mapping versus put mapping or whatever. Okay, so we have our very simple schema mapping to query mapping. I want to introduce some real data here. Okay, so let's create a real data. So we're going to say CRM service, whatever. You know what? And we're going to have a little CRM, and we need some data. So this will give us. Let's use a type called a customer. Oh, nope. Customer that will have an integer ID and a string name. All right, good. And we're going to say return a stream of customer. Okay, get customers. All righty. And we're going to have a constructor here. Very simple. And I'm not going to bother with a full database. I could. It would be easy, but why? I'm just going to keep this as simple as I can. We're going to have a in-memory database of customer data. Okay, so map of integer to customer db new concurrent hash map, etc. All right, good. So there's my map, my fake data, and I'll say list.of, and let's put some people who are on the Spring team. Let's see, Brian, Madura, let's see, Olga, Violetta, Yushin, me, I'm on the Spring team, right? There we go. I forgot about me. Stefan.
I have to greet Violetta. She's now here in Sofia.
Yeah, she's awesome. So there's names, right? Let me see. That's 1, 2, 3, 4. Is that 8? It looks like 8. So I'm going to take each one of these names, and I'll say for each name, let's just add it to the database. So I'm going to create a new method here, add customer, given a name. Okay, and we're going to just we'll create that behind the scenes, and add customer. We're going to say we need a private final atomic integer ID equals new atomic integer, and we'll say this.db.put this.id.increment and get new customer. Whoops, no, not that one. New customer, passing in, let's see here, we can just actually stash this variable, new customer I name, and we want to just put one single value. Okay, return this dot db dot get I. Okay, trivial, simple, nothing special here. But now we have some sample data in our collection, and actually we can just get rid of that and get rid of this and get rid of that. Very good. Okay, so there's our sample customer database that we're going to initialize here in the constructor one time when the application starts up. And now when somebody wants the data, we say this dot values. We can say flux dot from iterable blah. Okay, pretty trivial. Again, you can imagine how this would work with a database. There's nothing special here. That's why I'm not going to bother with all that. Okay, so we've got our service. Let's go ahead and restart this and make this available as an endpoint. So we'll go here and we're going to say query mapping publisher reactive stream of customers, right? And it could be a collection as well. This dot customers, and we want the CRM, right? We're going to inject the CRM here, service that we just created, and we're going to call this CRM GraphQL controller, private final CRM service. Okay, and inject that into the constructor, and we'll say return this dot CRM service dot get customers. Et voila. Let's go ahead and restart. Okay, so now I want to go back and change my schema to reflect the fact that I have more than one customer. So I can say customers, and I've got a bracket, and the bracket means I have more than one customer. I have a type here called customer as well. So customer ID and name, right? That's what we have. So I have a collection of customers. I have a more than one value of type customer. Let's go ahead and restart this and see what we get. So CRM service.get customers, query customer, whoops, refresh. We want to say customers. Now I cannot just see if I try that, it doesn't work. I must specify one of the subfields. With GraphQL, the objects that get returned have a type. You can see the schema there, right? I can see that this thing knows about this type called customer, and it knows that there are two subfields that I must either specify. Now, this is not a problem. GraphQL is really great because it makes it easy for you to selectively load some or all of the data. This is why it's such a good fit for people who want to connect their clients to the different microservices, because you don't need to use all the data. Let's suppose you want to have a search screen where you search for results, and it just shows you the title and maybe the summary. But then when you click on the result, you see the details. Normally, this would be two different engines, two different API calls. But with GraphQL, it can be the same one, and you only ask for the data that you need. So here, I'm specifying that I want the name data and the ID data. Whoops. So I go here, I can prettify it, I can make a request, I get the name data and the ID data. Great. Okay. So now I have I've got the ability to read data. Now, this is a query, right? Remember I told you about a query? Well, what about updates? Well, this is very important in GraphQL. If you want to update something, you use a mutation mapping, right? So we're going to do mutation, and this is another well-known type. So adding another customer. Okay, add customer, string name, and this will be an argument, of course. And my job is to return a new customer. So I'll say this dot add customer, and add customer is in the CRM, right? So I'm going to go over here. I'm going to create a new method to add a customer here. I'm going to make this public, basically. So we'll go back here and we'll say mono of customer. And we'll just turn this into a real endpoint, right? As though we had a real endpoint. So we'll say mono.just C. Very good. Okay. So now I've got an add customer endpoint. I want to expose that using a mutation mapping. Okay. Mutations are how you change data on the server side. So I'll say add customer, passing in the name, and I'll just return that. Okay. Very good. Very simple. Very good. Now, the nice thing about mutations is that it's very clear what you're doing. So first of all, let's go ahead and add this mutation. And then we'll say type mutation, and the type is called add, the filter, the field is called add customer, going to take a name as an argument, and it's going to return a customer. So the only thing different about this syntax compared to this and compared to what we saw earlier with hello is that it's in a type called mutation. It's exactly the same thing. And this is one of the nice things about GraphQL. There are three things you can do. You can read data with queries, you can read long-lived connections of data with subscriptions, or you can update data with mutations. That's it. There's no arguments, there's no fighting, there's no, is this RESTful or not? Do I have to use put or post to do an update? Do I have to send 201 or 200 or 202? There's none of that. There's no like religion around this, right? It's just very simple, very clean, very easy. You want to make changes to the data on the server, you use mutation. That's really nice for people like me because I don't have a lot of hair left, and what little hair I have, I want to keep. I want my hair. So mutations are good. Mutations are simple, right? So this is a mutation mapping. Let's go ahead and restart this. Something is already running on that port, which of course is this. Okay, so now let's say I've got these customers, right? 1 through 8, but now I want to also update the data. So I'll say mutation, refresh, add customer, name is going to be Sebastian. Okay, and the data that I expect back will be this. What happened? Whoa. I've got a issue here. Oh, recursive. Don't do that. Yeah, my poor API is very sad. I'm glad that actually stopped itself. Okay, so refresh. There you go. I've got a new customer. Got the name. There we go. So if I just keep doing that, you'll see the number keeps incrementing. And now if I go here, I can go and I can say, give me all the data, give me all the customers, ID, and you can do commas here, by the way. It doesn't have to be new lines, and name. Okay, great. So now I've got my customer data. I've shown you how to do a mutation. What if I wanted to add some data about when this customer was added to the database, like a date, okay? Well, let's go back to my schema, and I will say that this has an enrollment date, okay? And it'll be of type string, okay? Now, the thing is, there is no official type. You can create one using a scalar, but there's no official type in GraphQL for dates. And this is one of our first chances to see some of the power of GraphQL in hand. So what we're going to do is we're going to create a new resolver, right? These methods, these controller handler methods, ultimately, they get turned into data fetchers, which is what you saw earlier. If you've used GraphQL in some other context, however, you've seen the idea of a resolver. A resolver is a function that gets involved or invoked whenever the engine, the GraphQL engine, needs to return some data. So let's go back and we're going to create a schema mapping. And the type this time will be customer, and the field will be the enrollment date, right? So I'm going to create a resolver for a particular field on a type, just like you saw me do with query mapping, except now it's my own custom type. It's not a well-known special type. And this is one of the real powerful things about GraphQL is that you can have resolvers for individual fields in your schema that maybe don't exist in the objects behind the scenes. So it's very easy to create a view of the data for the client that doesn't exactly map to what the real world implementations look like behind the scenes. Okay, so now I'm going to say, give me the enrollment field, okay? So, and I need to, in order to give you the enrollment, I need the customer reference, don't I? Well, I don't have a type, I don't have enrollment here, right? Enrollment. So I'm going to go ahead and add that to my record. Let's see here. Customer. And this is going to be a date, right? It's an actual date. I'm going to call this enrollment. And now when I go here, I'll have to pass in new date, all right? And now when I go back down here, I want to actually take that date, var date, and I want to turn it into a proper value. Well, of course, I need a string. And in order to get that string, I'm going to do something that I don't like to do very often, which is write date formats. So let's see. Var SDF equals new simple date format, and then the string is YYY MM DD T HH MM Z. Okay, Good. So there's this. That's my simple date format. These are not thread safe, so you should do something like this: private final thread local simple date format SDF equals new thread local. Okay, and then you say if this dot SDF dot get should equal null, then this dot SDF dot set blah blah blah. And of course, our simple date format, we can just stash it there, and then we can return that result. So we can say, okay, let's extract this out into a method here. So simple date format, get simple date format. All right, return this dot SDF dot get. Okay, private. Good. So there's our very trivial simple date format, the kind of code I don't like to have to write. Okay, so return this dot get simple date format dot format date. All right, so now I am controlling how this enrollment field gets rendered, even though it's a date on the actual object. It's going to be a string for the client that cares about it, right? So let's go ahead and restart this. So okay, restart the data. I get the same records, but what if I want the date data, right? So I can say, whoops, let me refresh here. The schema has to get reloaded. There we go. So I ask for the enrollment. There we go. I get a string back. Now notice that this string, like if I were to put a breakpoint or to log something out, if I say system out enrollment for customer, customer.id, if I were to put that there, whoops, I restarted the wrong one. It's going to be the app. There we go. Restart. If I leave that there, you'll see that it gets involved only when I ask for the enrollment data. So, I get enrollment for this. Okay. Now we clear. Now we don't ask. Now we get that. And there's no data. So I'm not invoking this method unless somebody asks for that data. So even though there's a computational cost to this, I don't care because I'm not using it. I don't pay for it if I don't use it. That's one of the real powerful things about GraphQL, right? Is your ability to mix and match, to provide, to mesh together the whole object graph independent of the underlying representation using this data. So now let's suppose we had order data. So we have types of customers. Let's suppose that we also had types for order data. Okay, so order, and I'll say ID is ID, and we'll say customer ID is ID. And again, I'm going to create another view of the data here. I'll say orders, and I'll return order. Okay, so very, very simple example of the order data. Now let's suppose I wanted to add that. Well, okay, I'm going to go back to my CRM, and we're gonna create. I'm just gonna fake it, right? I'll just create a list or let's just say a list of order. Okay, and I need to actually create a type here called order. So record order integer ID integer customer ID. Okay, and I've got two now. I've got to get rid of the original one. Goodbye, thank you. And we're gonna say get orders for integer customer ID. Okay, so I don't have a database here, so I'll say var ID equals 1, ID is less than some number, so we'll say var max equals math dot random times 100 or 1,000 or whatever int. All right, good. So there's our orders. We'll say var max ID is less than max ID plus plus. We'll say var, we need a list here of records. So results equals new array list of order. We're just going to add that to the graph. So we'll say results dot add new order, and the order type will be ID on the left and customer ID on the right. So voila. Good, and return results. Okay, so we're just synthesizing some random data here. Okay, now again, this could be another network call, right? I could be calling another reactive stream to get this data. This could be expensive, right? Let's say thread.sleep 1,000 milliseconds. Okay, and I'm going to add throws exception. So it's going to sleep for 1,000 milliseconds. Now I want to get that data and return it when somebody asks for it for the customer. So I'll say schema mapping type is customer, and the field, of course, is the order data. So I'm going to say list array list of order, orders for the customer, and I'm going to inject the root customer type here to get that data. So I'll say return this.crm.service.get orders for customer.id. And of course, I got to turn this into a stream of just whatever. Now, again, I'm making a network call here. I'm making a network call that might take a little while, right? So there's an extra cost here. What is this? List of orders. Oh, okay, just list. Is that okay? Good. Everybody happy? So let's go ahead and restart this. I've got a cost. Okay. Customers. Good. There's no problem, right? I've got the data. I've got the enrollment data. Good. No problem. Let's refresh. Now, I want the ID and I want the orders data. And the order data has customer ID and ID. Look at that. I'm calling it. I'm getting back the results in a serialized fashion, right? It's giving me all the results for all the different things at the same time. So let me see here. What's a different way to do that, right? Customers, blah, blah, blah. I don't want to block the actual method. More realistically, what would happen is you would call a network service using a reactive non-blocking HTTP client, or you would call a reactive RSocket endpoint or reactive HTTP endpoint, in which case you would have you'd have a reactive stream that gets returned back. Because we had 8 records, we just waited 8 seconds. More realistically, you would have a call that might take some time, but the client would get the result would be resolved immediately. You'd get a mono of list of T. There would just be no data. And so I'm going to synthesize, I'm going to create a fake version of that using a delay element here. And what that's going to do is it's going to give us back the mono of list, which is like a completable future of list, immediately. And then we'll resolve it later. So now I don't wait for all 8 of them. Because it's a reactive type, I only waited 1 second total and I got all the data. Look at that. I've got all the orders for all the records in my graph, right? Very, very powerful. And the reason this is so is because this handler method, this controller handler method, this resolver returns a reactive type. So yes, I'm doing something terrible. I'm doing n+1. I'm calling all the customers, and then for each customer, I'm going out and getting all the orders. But because I'm using reactive types, it's concurrent. It's doing scatter gather service orchestration for me. And yet I don't have to pay the cost of figuring that out. There's no threads, there's no runnables, there's no countdown latches, no executors, no semaphores, no phasers, nothing. It's just very simple, easy to understand code here, right? So I love this about GraphQL, is that it makes it easy for us to build data integration layers in a reliable, scalable way without having to worry too much about how the concurrency works or anything like that, okay? Okay, so now I've shown you how to write this code. I've shown you query mappings and schema mappings. We should test something. I always think we should have at least one test, certainly, right? So let's go back to our test code. And what I'm going to do is I'm going to build a simple test to talk to our downstream controller, our API. So what we're going to do is we're going to say at enable. Oh, first we have to get the dependency actually first. So I have to go back to my build, and we'll say add this in GraphQL. I'm going to say GraphQL. This will get changed, I hope. It's a little confusing right now, but GraphQL Spring GraphQL test. Okay, re-import this. Thank you. And I want to test this in my code, so I'll say enable auto configure GraphQL Tester, and then I can just inject the private web GraphQL Tester. Okay, and I'm going to inject that, and I can use that to test my endpoint. So let's say I want to go to here, and what's a very simple example so I don't have to waste too much time. Query hello string. Okay, so we've got a hello endpoint. Go back to our controller. Where's our simple one? So we're kind of short on time. Query mapping string hello. Okay, return hello world, right? Okay, so there's this. Now let's go back to our tests here, and we're going to say var query equals. I love multi-line strings so much, y'all. So here we go. Query, hello. That's it, right? That's our query. And we're going to actually use the GraphQL tester. So web GraphQL tester.query, query.execute path, and the path will be just hello, right? And entity will be of type string, the results, that is to say, and we're going to say the string was going to match this predicate. So we'll say s dot equals ignore case or whatever contains. What did I? It says hello world, right? It should be that exactly. Good. All right. So very simple test. Let's go ahead and run this and see if it works. Run context loads. Good. Now, of course, we should let's make sure it's negative as well. So if it doesn't work, we should see it fail now. Good. So that we know that test is green because it's working. Good. So now you have testing support. We have queries and we have mutations. I did mention another kind of record, which is a subscription. Subscriptions are great for long-lived data. And you know the kind. These are all over the place. Let's say you have stock data or sensor data or whatever. You can use subscriptions. And subscriptions are great because they're just another kind of read, right? So I can say subscription mapping, publisher, whatever. Let's create a type here called record, system event. I don't know, whatever. String message, or actually message, and then we'll have a date. Okay, date. So there's our system event, and we're going to have a reactive stream of system events. So system events, and we're going to say system event, and I'm going to create a stream. So var events equals stream dot generate new supplier system event. Et voila. Good. New system event, passing in error, new date. All right. And we're going to create that stream, and we're going to say return flux dot from stream events, and I'm going to delay elements. So I'll have a delay of 1 second between each element. It's an ongoing stream. And I'm only going to get the top, let's say 100 events, just to keep it simple. Okay, so now I'm going to have an ongoing stream of results based on this new supplier here. It's just fake data, right? System events. Okay, so subscription mapping. Now I'm going to create another type in my schema called subscription. So type subscription, and what did we call this? We called it system events. So system events, and here it's not even though it feels like it should be system event like this, it's actually just one because it's a subscription. Okay, so we have to create the type called system event, and here we go. And the system event type is a message and a date. Oh, we need to actually. Oh yeah. Okay, same problem. So we will say that the system events, where is that system event? Here it is. Query mapping type, schema mapping type, system event field equals date, string, message, string, right? So there's this. I'm going to turn this date into a string as before. So date, system event se, return, get simple date format dot format event dot date. Okay, there's our very simple stream. Let's go ahead and run this. But the thing is, we can't use this. We can't test this from GraphQL. This is great if you have a long-lived connection. And one place where you can see this is really useful is when you're creating JavaScript clients where you need status updates and so on. And so what I'm going to do is something I don't like to do, something I try not to do in polite company, but I feel like there's no other way forward, so I'll do it here. I am going to write JavaScript. So we're going to create a new file here called static. And in that, we're going to create a new file called index.html. And in this, we'll create a body, and we'll create a script tag. And now I'm going to hopefully piece together the right version of this code by copying and pasting, which is something that you should never, ever do, ever, not even when you're all by yourself at home and no one is looking. So there's my GraphQL WebSocket API, right? And the way I'm going to use this is I'm going to talk to my GraphQL endpoint using WebSockets. So we'll say GraphQL WebSocket, 60 seconds, no problem. GraphQL WebSocket path equals GraphQL. Okay, so we have a HTTP endpoint at /GraphQL. You also have a WebSocket endpoint. So let's go back to here, and we're going to say const URL equals localhost 8080/GraphQL, and const client equals GraphQL ws.create client URL. And what else am I going to do? Then from there, we're going to say we need to listen for the load event, right? So this all happens in window.add event listener load, and good. Okay, so creating a little event handler, and then when the window loads, then we will respond to it. We'll say, okay, client.subscribe, and we're going to pass in a query, and the query will be const q equals backtick, right? It'll be subscription system events and date. Okay, so there's my query. I'm going to subscribe to that, and then when I subscribe, I'm going to pass in a callback. Okay, so it'll be next. It'll be callback data, and then error. Let's just say console.error, and complete will be console.log. Done. Okay, so we're going to get this data, and here we're going to print out the results, and the results are going to be, const results equals data, and then system events. Okay, so there's that, and I'm going to say console.log result. Let's see if this works. Fingers crossed. I hate debugging JavaScript live. I'm not sure if that's actually required right here. Okay, take 3. So good, restart. Okay, so go back to localhost 8080. Okay, console, unexpected token. No, where is that unexpected token? Data, next. Did I miss something? I mean, whatever, let's not bother with this stuff. Function. I don't have time to worry about this. Yeah. Okay, take 3. Unexpected token function. Subscribe. There's the query. There's the subscription script type. No, that's not it. Well, okay, my friends, I don't know. You would usually write something like this, and you'd get back the subscription. And the point is, this is a nice API if you can get it to work. I obviously have failed here, but you get it to work, and you can get the results as you expect them. And the nice thing about this is that you're using the same API no matter what you're doing. So if you're doing mutations or queries or long-lived subscriptions, it's the same exact code, and it's using WebSockets, right? And this is the nice thing about GraphQL is it doesn't purport to be HTTP. It's not RESTful. It's not supposed to be. It's a way to get data across the wire in a way that the clients can use and that benefits them. I'm showing it to you using HTTP and with WebSockets, although I have to figure out what that issue is. But the point is,
I think that people even figure it out after error. So that's like double colon after something like this. Fair. So the chat is. So, Vladislav, if you're there, just point us.
Yep. You see the error?
I think that will be a double column somewhere. No. Okay, sorry. Yep.
You don't see it?
I think that errors should be. Look at the error, and then it'll be this error. No.
This
Line 19, then error, and function.
19.
Yeah, line 19.
Oh, missing my semicolon.
Yeah.
Oh, I hope this works. Do you think it'll work?
Yep. Let us.
There we go. Thank you.
Yes.
So there you go. So you can see I'm using now subscriptions to get the data back. And again, I'm not paying for anything more than I want. I get just the dates.
Yeah.
I can add the messages, etc. So that's GraphQL, my friends. We didn't get enough time to look at security. There's actually a Spring security support here as well. It works just like you'd expect it to work. Very trivial. This is only the beginning, obviously. So there's a lot of really interesting opportunities here that we get by using GraphQL for our data integration layer. I simulated some requests. I said, I'm going to call the order data. I'm going to call the customer data. Imagine that instead of doing that all in memory, that's now different microservices. And they return reactive streams of customer and reactive streams of order, or completable futures of customer and order. Now you can see the possibilities. The client gets a nice, introspectable, type safe, discoverable, easy to enumerate endpoint called API.whatever. And then you can have however you want. You can use RSocket in the backend or gRPC or whatever to actually build the services. This is the best of both worlds. The client wins and you win. I want to thank you so much for your time, everybody. Spasiba. I hope you're all doing well, and thanks so much for having me. And I hope we can hang out next time. And also, thanks for helping me fix my code.
Oh yes,
JavaScript.
This is from actually several people, Vladislav and Pavel and all of them. So from my side, I want to say that we have questions. So that's why I encourage you, because we have no time on air, to move to the Zoom chat, and not actually Zoom room. And I will ask you there the question, and I encourage the people who ask the question to join us as well. And we will give the air to other speakers. So Josh, tremendous pleasure to be with you, at least virtually. You're a
Likewise,
hero.
My friend.
You did a talk with a booster vaccine. You're a hero. So yes, be like Josh, like do vaccination, all that stuff. And thank you so much. And it's really a great pleasure and really informative talk. And let's move to Zoom room and continue there. Thanks so much. It's been a pleasure to be a pilot here. Thank you. Bye-bye.